Hi there, this is Penelope. This is a video on how to differentiate from first principles and some questions associated with the function that we're looking at. Now, as engineers, you're not going to be asked to differentiate from first principles. What you do is, once you kind of understand what's going on, then you simply use a table of derivatives or one of the processes like product rule or quotient rule or whatever. But in order to understand how differentiation works, differentiating from first principles is a useful thing. So we're going to answer all these questions in turn. They're repeated on the slide, so this is what we're looking at. We have a function, y equals 2x squared minus 5x minus 12. It's a parabola. It cuts the x-axis at negative 1.5, 0 and 4, 0. And the point that we are concerned with is this point at the bottom here, the point 1, negative 15. And what we're doing is we are first of all differentiating from first principles, then we're finding the rate of change at that point there. And knowing what you know about straight lines, we would expect it to be negative. Then we need to find the equation of the tangent, which is the red line. And the normal, which is the blue line, which is just simply the one that is at right angles to the tangent. Right, derivative from first principles, that is where we say that the derivative is equal to the limit as delta x tends to 0 of the function when we put in x plus a little bit and subtract our function of the original and divide it by delta x. Now, from here onwards, it is just algebra. So we're going to find the limit. Now we have to put x plus delta x into the function. So I might just write the function here. Okay, so I'm going to put in x plus delta x instead of x. I need the 2 outside there. So that's putting in x plus delta x. And then I'm going to subtract the straight out function with x in it. And then I'm going to divide that, so put an extra bracket. Then I'm going to divide that by delta x. So expanding all the brackets, two x squared plus 4x delta x plus 2 delta x squared minus 5x minus 5 delta x minus 12, whoops, running out of space, minus, I'll just do that there, and divide it by delta x. So at the end of that line there, I need to subtract 2x squared minus 5x minus 12. Okay, when I do all of that, I suggest you stop the video there and do it yourself. Now what I've got left is 4x delta x plus 2 delta x squared minus 5 delta x to be divided by delta x. And then if I do the division, I have 4x plus 2 delta x minus 5. And then if I think about what happens to the terms that have got delta x in them, 4x hasn't, so that's going to stay unchanged. As delta x goes to 0, 2 times that will go to 0, so that goes, and we're left with that. Now, you know that that is indeed the derivative of 2x squared minus 5x minus 12, but that's because you know how to do it. But this is how it was developed. This is how it was done. This is what the definition of a derivative is. Now we're going to find the rate of change when x is 1. We have just found that the derivative is going to be 4x minus 5. So when we pop in x equals 1, that's going to be negative 1. So we've just substituted that in. Now that makes sense because the slope is backward sloping. So yep, that's all good so far. Part C. Now this says find the points at which the line through 1, negative 15 with some unknown slope cuts the graph. Okay, so at this stage let's suspend belief about what we've seen in the original graph. So we've got a parabola, we've got a point there. At this stage it's not correct, this is just what we have to think. So that may be 1, negative 15, and we're saying that this line has a slope of m, and we're trying to find that other point there where the line goes through it. Okay, now as it happens, this is something you should always think about, whether you've got the graph or not. 1, negative 15 is on the line. So it's not just some random point, it is actually on the line. Okay, one of the ways of writing out a straight line when we know the point, and we do know the point, is this version of it. And we know we're trying to find the intersection of that and the function, the parabola. So what we need to do is to make that equal, or to find the x's where it's equal, because this is y and this is y. This will find the point of intersection. Okay, expanding all that and shifting everything over and factorising. Now we've got a quadratic, and that means we can just use the quadratic formula, which again I suggest you stop the video and do yourself, and you get that x is equal to 5 plus m plus or minus m plus 1 over 4. Now doing each of the roots in turn, it doesn't matter which order that you do them in, so x is going to be equal to, let's do the plus root first, so that would be 6 plus 2m over 4, which we could say was 3 over 2 plus m over 2, or a half m. Or doing the minus root, then x is going to be 5 minus 1 plus m minus m over 4, which will give you nothing, plus 4 over 4, which would be 1. And if x equals 1, we don't actually have to work it out, but we could, that y is equal to negative 15, and I should go back and putting the first x value back in, I would find that y was equal to a half m squared plus a half m minus 15. That's by, excuse me, substituting. So it was, as we expected, one of the points was 1, negative 15, and all we know so far is that this point here is x is 3 over 2 plus a half m, and y is a half m squared plus a half m minus 15. Okay, now the question says, well, actually, let's think a bit more towards what we are intending to do. We're intending to find the equation of the tangent, let's say that instead of these points being like that, let's say that actually it's just 1 point. So instead of this, but actually we want them to be together. In other words, we are thinking instead of the line being a chord, it's a tangent. It's the same point. Now we know that x is equal to 1, and we also know that x is equal to a half m plus 3 over 2. So what we really need to do is we need to find m to make those points the same. And if you do that, then 1 equals a half m plus 3 over 2. Now we know that. We already knew that the slope of the rate of change at 1 was -1. So it should all be coming together. So we knew that, but we knew this. All right, now the crux. Find the equation of the tangent to the graph at that point. Now we know the slope is -1, and we also know that the slope of the tangent is the slope of the curve at that point. So what we need to do is we need to find a line through 1, -15 that has a slope of -1. So we can use this format that says -1 times x minus 1 minus 15. We could rearrange that, and then we get y equals -x minus 14. The last question says find the equation of the normal. Now the normal is the one at right angles to the tangent. And the slope of the normal times the slope of the tangent is -1. So nm equals -1, where n is the slope of the normal and m is the slope of the tangent. So if n times what we already know, m is -1 equals -1, n equals 1. So again, we can use the version like this, and we get that y equals x minus 16. So that then gives us, we had the graph, we had the point down here. Oops, there's the tangent, and there's the normal like that. Okay, thanks for watching.